Assalamualaikum warahmatullahi wabarakatuh. So I will introduce to you guys our group member, which is consists of 5 students. Our group member is Muhammad Faris Aiman bin Muhammad Fauzi, Muhammad Kari Izzat bin Kasman, Muhammad Aiman bin Ahmad, Muhammad Aidil Fazli bin Munawir, and Muhammad Irfan Azim bin Hilmi. Assalamualaikum warahmatullahi wabarakatuh. So this is the introduction for our copy container database. Our group project name is Database Design for Copy Container. Course code is ICT 200 and group is RCDCS 14334E. So the purpose of this database design is to provide an organized system for managing customer order, menu information, payments, and inventory data at copy container. The second one is to improve the accuracy and efficiency of daily cafe operation by storing all business data in a centralized database system. The third one is to monitor ingredient stock level automatically and reduce shortage of imported item during business operation. And the fourth one is to generate daily sales and inventory report that can help management monitor business performance and support decision making.
Alright, so I will be explaining about the company background of Copy Container. The Copy Container was established in 2025, located at a strategic area near residential and student communities. They opened the shop as a coffee shop business, known for its uniquely container style concept and modern atmosphere. Serve customer through dine-in and takeaways menu that includes iced coffees, hot beverages, chocolate drinks, snacks, and desserts. For the daily operation involve handling customer orders, preparing drinks, processing payments, and managing ingredients stock such as coffee beans, milk, cup, and syrups. As the business continues to grow, Copy Container needs a more organized system to manage customer orders, sales record, inventory, and daily business operation efficiently.
Okay, now we move on to the problem finding in data management. The current data management process at Copy Container is still handled manually, which is caused several operational problems during daily business activities. Ingredient stock such as coffee beans, milk, cups, and syrups are not updated automatically after each sale. Inventory checked manually. This will cause inaccurate stock records and shortage of important ingredients. Daily transactions are recorded manually. Staff spend more time to calculate total sales and preparing reports at the end of the day. This will increase the risk of human errors and inaccurate financial records. All business information is stored in separate files without a centralized database. This will make it will make difficult to search precious records, monitor business performance, and generate reliable reports for the future use.
The Purpose Coffee Shop Management System for Copy Container is designed to manage customer orders, payment, menu information, and inventory in one centralized system. It automatically calculates the total payment for each order and update ingredient stock after an order is completed. The system also helps staff monitor inventory level and identify low stock item earlier, reducing the risk of shortage during business hour. By implementing this system, Copy Container can improve service quality, reduce human errors, and manage business data more effectively.
Today I will explain the relationship in our entity relationship diagram ERD for our container management system. First, the customer table has customer ID as its primary key, and this key become a foreign key in the order table. This shows that one customer can place many orders, while each order belongs to only one customer. We can see the staff table has staff ID as its primary key, which is also foreign key in the order table. This means one staff member can handle many orders, but each order is handled by only one staff member. Next, the order table has order ID as its primary key, and it uses as a foreign key in order item table. This relationship means one order can contain many order items. The menu table has menu ID as its primary key, which is also foreign key in the order item table. This shows that one menu item can appear in many order items while each order item refers to one menu item. Next, for inventory management, the menu table is connected to the inventory table through the menu ingredient table. Here, menu ID and inventory ID are foreign key, showing that one menu item uses many inventory ingredients, and one inventory item can be used in many menu items. Next, the supplier table has supplier ID as its primary key, which is a foreign key in the purchase order table. Similarly, inventory ID from the inventory table is also foreign key in the purchase order table. This means one supplier can provide many purchase order and one inventory item can be purchased many times. Finally, the payment table is linked to the order table through order ID, where order ID is the primary key in the order table and a foreign key in the payment table. This represents a one-to-one relationship, meaning each order has one payment record and each payment belongs to one order. In conclusion, this ERD represent the complete workflow of the Kopi Container Management System.
For this query, our goal is to get a summary of our warehouse stock levels. Instead of reading individual ingredient rows, we use aggregate column function to look at the entire table at once. Count inventory ID tells us how many different types of raw materials we manage. Sum quantity gives us the total combined volume of all ingredients currently sitting in stock. Average quantity calculates the baseline average stock level across all items. This gives management a quick and high-level view of our inventory health so they know if warehouse is overstocked or understocked. For statement 2, here we are analyzing the price distribution of our food and beverage products grouped by their category, like coffee, non-coffee, or dessert. First, the database uses group by category to split the menu into separate groups. Then, for each group, it extracts the minimum price and the maximum price. Finally, it uses average price combined with round 2 to calculate the mathematical mean price clearly formatted for Malaysian ringgit cents. This helps us see which product categories are our premium high-ticket items and which one are budget-friendly. In this query, we are evaluating employee performance by tracking how much revenue each staff has generated. We start with an inner join to connect our staff table to the order table using the command link staff ID. We use group by staff ID so that all calculated cells are neatly pulled under each employee's name. The crucial part here is having clause, unlike which filters individual rows, having filters data after it has been aggregated. In this case, it blocks out any low performing records and only reveals staff members whose total processed revenue exceeds 20 ringgits. This query acts as a KPI tracker to identify top performing baristas and cashiers. Query focuses on our supply chain expenses. We want to see how many transactions we've made and how much money we've spent with each supplier. We join the supplier table with purchase order table. We use group by to separate the financial metrics per supplier business identity. We apply having count in bracket purchase order ID more on equals to 1 as a final filter to isolate active suppliers, ensuring that all our active vendors with zero transaction histories do not clutter our management report. This allows our purchasing department to quickly see which supplier we interact with the most and where our procurement budget is going. For This final question, we implemented a nested query structure, which means executing a query within a query. The database solves this from the inside out using 3-layer system. First one, deepest layer. Select average quantity from order item runs in the background. It looks at every single receipt row in history and find the baseline average quantity a customer order. For example, let's say the average order size is 2 items. Next, the middle layer. The system looks at the order item table and selects the ID number, menu ID, of any product that was ordered in the batch higher than that market average. Finally, the outer layer. The main select statement takes that list of high volume IDs and matches them back to our master menu catalog to extract the actual reader-friendly menu name and retail price. This is a powerful business intelligence tool. Instead of hard coding a number, the query dynamically target and display our top trending or bulk purchase menu item based on the real-time sales behavior.
Okay, so for the conclusion, the coffee shop management system helps copy container manage order, payments, menu, and inventory in one system. It makes daily works faster, reduces mistakes, and keeps inventory up to update. Overall, the system improves cafe operations and supports the business future growth. That's all for me. Thank you.